Okay. Domain and range. That means x and y, right? Domain is x, range is y. And what they're saying is, like, Jordan, how many x's can I get? Like, what kind of x's can I use? Can I use all of them? Could I plug in anything for x? Because if I can, then I just go all real numbers. Cool. Simple. Right? So, we have to remember about logarithms. One thing about logarithms. Do you remember what it is? You can't take a log of a negative number, and you can't take a log of 0. Okay? Anything above 0, you can deal with. Right? So as long as this, right, does not go to, because we don't care about this. Who cares about the +2? That doesn't change the log, right? You're taking the log of this number, because that's what's in the parentheses, correct? So, if all we're doing is taking the log of this, and then adding 2, then all I care about is that part. So that's the one thing they're testing you on. Okay? And then the other thing I want to make sure is that this, right, is greater than 0. Can I solve that? How do I solve it? Plus 1. So 2x has to be greater than 1. Then what? Then what? Divided by 2. Okay, so then x, right? X has to be greater than 1/2. And that's your domain. D such that. Okay? That wasn't that bad. Okay, so now it has to be greater than that, right? So it can't be less than that. So that's the lowest it can be. So that puts a restraint on y, right? So what happens when we put that in for y? You know, what is y when x is 1/2? Right? So you plug it in. You say, okay, 1/2 times 2. What is it? Becomes like 1, yeah? 1 minus 1? 0, right? Oh crap, that's when it goes to hell, right? So then we think, okay, let's go a little bit bigger. Let's go like, let's go like 3. Let's see what 3 is, right? So, or in this case, what if x were a little bit bigger than 1/2, right? And a little bit bigger than 1/2 would be like what, 51 over 100? That'd be a little bit bigger, right? But that's kind of hard. So let's just say it's 1 for right now. Put something easy in. Okay, so 1 times 2. 2. Okay, and then 2 minus 1. 1. Okay, and then 3 to some power equals 1. 3 to what power equals 1? 3 to what power equals 1? What does that have to be? You remember? 0. Good. Okay? So that means this is 0 when we plug in 2, right? Or what did we plug in? No, we plugged in 1, right? So when y was 1, that went to 0 and it became 2. Okay? Alright? And so we want to see what is it going to. So when this went to 2, right? That moved that range, right? That moved that range from being 0. Do you remember what the log is going to look like? Right? 3 to some power, what that's going to look like? You remember at all? Like what that? It's going to look like this. It's going to look like this. So think of it like if the exponent is very, very, very small, right? If it's 0, it's going to be 1, right? Right? And if 3 to a really big number, right, is going to be a really big number, right? So a really big number is going to be a really big number, right? But as that number gets smaller, right, then it goes, the shape of this, then the number gets smaller, right? Because you're saying a cubic, or one, to the 1/4, or like, the 4th root of it, the 5th root of it, the 6th root, the infinite root, right? So it's getting really small, but it never gets smaller than 0, right? Okay? So it's 1 less than that number, right? And if it hits 0 at 1/2, right? Then what's 1 less than that number where it hits 0 at? And it hits 0 at when x is 1, right? But then you can't reach 1/2. So the closer it gets to 1/2, right? X gets to 1/2. The smaller this thing gets, right? And then it hits 1 here, okay? And so you'll be at really close to 2, right? Because this can't get 0. It has to be bigger than this number, which is, so y, right, has to be bigger than 2. Because as soon as it hits 0, you can't take it. So it's got to be a little bit bigger than 0, which could be like 0.00000001, right? So that's going to make this a little bit bigger than 2. That's it. That's all we're looking for. And that's the domain and range, right? You found the range. The domain was pretty easy. The range, you have to think kind of outside the box. Like, what happens to this thing as this hits the lowest function, which is 1/2? Well, it goes to 0. What is 0 plus 2? 2, right? But it can't be 0 because we can't take a log of 0, so it has to be a little bit bigger than 0, which would make this thing a really, really small number, right? And then it would become 2, right? Plus a little tiny bit. So the range has to be a little bit bigger than 2. What about for this one? Now, x can't be negative. This is a little easier to think about, right? X cannot be negative, or it goes in the complex realm, right? Square root of a -1. Can't do it, right? Can we take square root of 0? Sure, it's just 0, right? 0 times 0 is 0, right? So x can be 0, but it can't be less than 0. So the domain such that x has to be greater than 0, right? Yeah. Okay. Feel me? Right? Now what happens when we take the square root of 0? What do we get?
Square root of I is -1.
Yeah. Well, what's the square root of 0?
0.
0. What's the square root of 1? 1. Square root of 2?
2.
Well, that one's a little harder.
Yeah,
It's like
1
point
point
something, right? But what's square root of 4? 2, right? Square root of 9, 3. Square root of 16, 4, right? So it just gets bigger, right? What's the smallest y was? Well, the smallest y gets is 0, and then it gets bigger, right? So your domain is x has to be greater than 0, but your range is the same in this case, because it's going to start at 0, right? Or equal. It could equal 0 in this case, though, right? So that's the difference here. These ones had to be greater. They could not hit that because you can't take the log of 0. But in this case, you can take the square root of 0, so it can equal 0 in this case. See how they're a little bit different? Okay? So that's the equals to's part. That's it. That's domain and range. You're trying to figure out where this function is going.
So is it only with logs where it has to be bigger than
Yeah, with logs, you can't take the square. You can't take a log of 0 or a negative number, right? It has to be what we call a natural. Well, not even a natural number, because natural numbers are 1, 2, 3, 4, 5, 6. So it has to be a number, a real number bigger than 0. Any real number bigger than 0. Okay. All right. So then we come back to this absolute. This is way back, beginning of the year. First day. How do we do this? Is that thing still recording?
Yep.
Okay, because it's about to run out because I'm taking too much time. But it's good. This is good time. All right. So first we set it up. Can this be 1? Can absolute value be 1? Yeah. Okay. So then m plus 9 could equal 1, right? What if the absolute value were negative 1? What does that equal? What's the absolute value of negative 1? Not sure. Can't remember. 1. Right? So it's just absolutely positive. That's whenever you think of absolutes, it's absolutely positive. It's always positive. It's never negative. So even if you come up with negative 8, it's 8. Does that make sense? But we want to come up with 1. Well, there's 2 ways to come up with 1 in this case. 1, right? And then negative 1. If it were negative 1, it'd still be 1, right? So then we need to set it up so that this is equal to negative 1. Okay? And in essence, if we want to be funky here, we flip the sign. Can you see how we flipped it? Never mind. Okay, so we flipped it upside down. That's just an equal sign, so it's kind of hard to tell unless you make one a different color. All right, so you have to flip the sign and you make it negative. Okay, and that way, when you end up with one of these, it looks like one of these. Does that make sense? If it's greater than here, then over here it's going to be less than. Does that make sense? Okay. All right. So then I just add, or I subtract 9. I get m is negative 8. I subtract 9, and m is negative 8. No, not negative 9. Closer. Negative 1 minus 9. I need $1 and I need 9 more. Negative 10.
Wait, negative what?
Negative 1 minus 9.
That was 10.
Yep. Negative 10. So those are your 2 answers.
You said negative 9 minus 1.
Yep. Negative 1 minus 9. 1 minus 9. Negative 1. Okay? Alright. This one's really complex but super simple. Anybody remember? 6 to some power, in this case negative 3n, is equal to 6 to negative n. How do I solve this? Now I'm going to show you a really easy one. 6 to the x is equal to 6 to the 5. What is x? 5. Right? Right? It's not that hard. These have to be equal, right? Because these are equal. I'm saying 6 in both of them.
So those are equal?
So these are equal. Negative 3n equals negative n. So now I just add n to both sides. Plus n plus n. I get negative 2n is equal to 0. So what do? Divide by negative 2, divide by negative 2. N equals? No. 0. Okay? And there you go. Pretty good?
Yeah, see, you had me on that.